Hello all. Today I am going to present my work of computer-aided diagnosis of breast lesion and skin lesion using delineation and classification approaches. These will be the table of contents where I will be discussing the 4 of my works during the course of my PhD. First work contains it is an interactive 2D medical image binary classification pipeline where image pre-processing is done as for image enhancement and where the extracted features from the pre-processed images are used in the neural network based classifier for pixel level classification. This is the proposed framework where the input mammograms are pre-processed and are sent to the feature extraction module, and the features from all the ensemble modules are concatenated and are given to the classification modules for later level classification into benign and malignant classes. This is the architecture wherein the hidden layer contains 7 neurons and output layer contains 2 neurons. These are the results where 88.6% of all the samples has been correctly classified into different classes. These are some of the results from the proposed architecture in comparison with the state-of-the-art models. This is the second work where the breast tumor detection network for ultrasound images using bidirectional, convalescent and dense residual connections. It contains encoder, bridge and the decoder section, wherein the encoder, bridge and decoder section contains a residual block whose architecture is shown at the bottom of the figure, and in the decoder section we have bidirectional convalescent units which contains an input gate, output gate, memory cell and a forget gate. The equation for the different gates are as shown in equation 1, where xt and ht are the input and hidden state tensors, and ht-1 is the output of the previous LSTM block. The architecture of the B convalescent is as shown in figure 7, wherein the forward layer and backward layer inputs from the corresponding encoder and the current layer are added together using the tan-h activation function and is given as output for producing output at the next layer. These are some of the result analysis on different image sizes. These are the corresponding segmentation results from the proposed method in comparison with the state-of-the-art segmentation methods. These are some of the visual results on the proposed method using the acquired dataset. These are the segmentation results from the second acquired dataset. These are some of the quantitative segmentation results on the second acquired dataset using proposed method. The third research work is a deep neural CNN model with CRF for breast mass segmentation in mammograms. It contains a segmentation approach using ROI-based breast mass images, wherein we have used the feature projection capability of group convolution and the feature reuse and combination patterns of recurrent layer-like paths. In the end, we have used a conditional random field as an image labeling or a structured learning technique which is used as a post-processing mechanism. This is the proposed architecture of an encoder block, wherein the encoder block contains 2 sub-blocks and each sub-block is connected using a group convolution layer in the channel-wise fashion, and along with the encoder block we have used convolution 1x1 block, convolution 1x1 as a residual connection which uses feature combination of the previous layer with the next layer. This is the proposed architecture wherein every encoder block in combination with the 1x1 convolution is the outputs of both the blocks are added together and is given as input to the next block. In the bridge section we have used heteros convolution which increase the field of view of the input kernels that we have taken. And in the end we have received semantic segmentation and the corresponding binary segmentation of the input images. After the binary segmentation we have used CRF, which is used for correctly annotating the segmentation maps by using pairwise edge potentials. These are the quantitative ablation results on the proposed model using different optimizers. These are the accuracy versus loss per iteration comparison of the proposed method using on different optimizers. These are the corresponding segmentation results and the quantitative comparison results of the proposed method in comparison to the state-of-the-art segmentation methodologies. This is the fourth research work where we have utilized attention-based deep convolution neural networks on the dermoscopic images. This model contains group normalization and attention gates which replace hard attention with soft attention for better pixel classification. At the output layer we have used Tversky laws that focuses on small and crucial lesion boundaries. This is the proposed architecture, wherein we have utilized group normalization layer in both encoder and the decoder section, and the bridge section contains the address convolution to increase the field of view of the kernels in the bridge section. This is the architecture of the attention gate, which distinguishes the feature responses in the irrelevant background with the high level contextual information. And in the output layer, we have used Tversky loss, which weighs false negative more than false positive and focuses more on the imbalanced data and the small crucial lesions. These are the results from the proposed architecture on different output on different loss functions, that is Tversky loss, focal Tversky loss, and the dice loss. These are the graph depicting the comparison of validation loss versus accuracy for 50 epochs using proposed method. These are the sensitivity and specificity analysis on the proposed method using the acquired RGB dermoscopic images. These are the corresponding segmentation results on the with frame and without frame input images. These are the corresponding qualitative result comparison of the acquired images on the proposed method with the state-of-the-art segmentation methods. Corresponding quantitative comparison results, which shows that the proposed method has produced better results than the state-of-the-art segmentation methods. Thank you. These are some of the references. Thank you.